So welcome back. Today we will do two questions, but again, before doing the two questions, let us have a recap of what we have learned. The first equation, y equal x tan alpha minus gx squared by 2u squared cos square alpha. This one is the equation of the path of the projectile. This one, x equal u cos alpha t, okay, it is an equation involving time as well as the distance x. The second equation, y equal u sine alpha t minus half gt squared, again it involves time. This time factor t, it is what sets apart the first equation from the two of them. Because the first equation, if you see, there is no time factor that is involved. So if you have a question involving time, naturally one of these equations or both of them will have to be involved. Let us recap what is x. X, it is this distance, and y, it is this height. So now let us do that first question. What we are having, you are throwing a projectile with some velocity u in this direction. This direction it is alpha. After some time it reaches a point P, and the elevation of this point as seen from O, it is beta. So we need to find the expression for the velocity. Again, if you take a look at the question, there is a time factor that is involved. So naturally we will have to use the two equations that we have discussed. Okay, so again, okay, xy, let p xy be the point after time t. So we are having that this point satisfies the equation of the path of the projectile, that is y equal x alpha minus gx squared by 2u squared cos square alpha. Again, this equation does not have time, the time factor, but if you see the question, we need the time. So we will be needing another equation, that is x equal u cos alpha t. Okay, for this question we won't need the other one, okay, as you will see. Again, what we are having, okay, beta is this angle, so this one is y, this one is x. So the third equation that you will be having is tan beta equal y by x. This first equation does not have time, so we have found another equation that involves time, that is this one. Again, this equation does not have this angle beta, so this equation contains beta. So all that is left, substitute this here and this one here. If you see the question, we need beta, so, and also you have this one y by x, so it is natural that we will divide equation 1 by x. Now we will substitute tan beta equal 1 y by x, tan alpha. Now we will substitute x. X is equal to u cos alpha t. So you will be having this after simplifying it. Okay, next what we will do, multiply throughout by 2u cos alpha. Okay, all that is left is simplifying. Okay, and then we will reach the answer. Tan, you can write it as sine by cos. Okay, so we'll keep the time in one side, the rest will transfer it to the other side. Okay, take common 2u, you will be having sine alpha cos beta minus cos alpha sine beta. This one you can write it as sine alpha minus beta. Okay, so we are done. U equal gt cos beta by sine in the second question. What you are having, okay, you are having some target. The distance of this target, we'll call it the range, be equal to r. If you throw the projectile at some angle, it will hit this point exactly. Okay, so let that angle, that proper angle, be theta. Okay, the velocity, it remains the same. Okay, let us call this angle as theta. So what is given in the question is this. if you throw it with another angle, it will not hit this point. Okay, it will may land here or it may go further. Okay, so what is given the question? If you throw it, the velocity in each case is u, so I won't write it down. Okay, u is always the velocity. If you throw it at another angle, alpha, as given the question, okay, it lands a feet. Okay, so this distance is a. Okay, this one, if you throw it at an angle, alpha. Okay, this angle, it is alpha. Again, if you throw it at another angle, beta. Okay, this other angle is beta. This huge angle, it is alpha. Okay, if you throw it at an angle beta, it will land b feet off from the target. Okay, it will land further from the target by a distance b. What will we write over here? R, it is the range when angle is theta. That is the proper range with the proper angle theta. R minus a, it will be the range when angle is alpha, and R plus b, it is the range when the angle is beta. Okay, so over here we don't need anything else, we just need the formula for the range. Okay, the range when the angle is theta, we have already learned. R equal to u square sine theta cos theta by g. 2 sine theta cos theta, we can replace it by sine 2 theta by g. Okay, we'll call this one as equation 1. R minus a, it is the range when the angle is alpha. So instead of theta, you will be having alpha. Cos alpha by g. Again, this one you can write it as u square sine 2 alpha by g. This one will be equation 2. And the third one, we will be having r plus b. Again, we'll do in the similar way, but when the angle is beta, so we will be having equal u square, I've written it directly, sine 2 beta by g. This question is actually easier compared to the previous question, because in this question all clues are in the question itself. Okay, so if you take a look at the question, we need a sine 2 beta, and also we need another term, that is b sine 2 alpha. So let us take a look. From the three equations, how will we obtain a sine 2 beta? It is natural that we will multiply this equation 3 by a. Similarly, how will we obtain b sine 2 alpha? We will multiply equation 2 by b. So again, we'll multiply equation 2 by b. Equation 2 times b. Okay, we will be having b. Next, what we will do, again, if you take a look at the question, we will be needing a plus b. It's natural that we will have to add this. Okay, next, what will we do? Okay, we will add 4 and 5. This one and this one will get cancelled, so we will get br plus ar. U square by g, you take common. You will be having, okay, you will be having this. Next, just substitute the value of r from equation 1. So if you take a look at equation 1, r, it is equal to u square by g sine 2 theta. So we are done.